All right, welcome back to the Chapter 5.2 video lecture series. In the last video, we finished looking at a 99% confidence interval for the Honeybee Waggle Dance. And I mentioned, don't forget, that the larger the confidence level, then also the larger the confidence interval. So if we were to take a 90% confidence interval, what would be Z-star be? How do we get this? Z-star comes from the normal distribution. We go to that normal distribution here on stat key. And if you see anything with Z or Z-star, that means do not change the mean and standard deviation. They should stay 0 and 1. For confidence intervals, we're always doing two-tail. And then you want to make this middle entry 0.90, 90%. Not 95. And then notice right here we have 5% each of the two tails, but the Z-star value is down here. Here's minus Z-star, and Z-star is 1.645. So why use the standard normal? Why use this Z-star? For one, Z-star is always the same. Whatever data you're doing, means, proportions, correlations, Z-star will not change. We have some pretty common confidence levels. For 95% confidence intervals, 1.96. That's why we use 2 in Chapter 3 in the confidence interval formula. For 90% confidence intervals, Z-star is going to be 1.645, and for 99%, it would be 2.575. I've had students ask, do they need to memorize these? I say no. You always have at least like a page of notes you can bring to a test. Or if you forget, be able to use stat key or another normal calculator to figure out these Z-stars. Right. Okay, let's look at another example. In March 2011, a random sample of 1,000 U.S. adults were asked, do you favor or oppose, quote, sin taxes? So taxes on soda and junk food. Now, most states already have sin taxes on stuff like alcohol products. There's a tax on alcohol, tobacco, that kind of thing. But this was asked about maybe more benign issues like soda, highly sugar products, or junk food. And out of 1,000 people, only 320 adults responded in favor of sin taxes. So I want to go through and give a 99% confidence interval for the proportion of all adults that favor these sin taxes. Okay, so I want to actually write this up, go over this in detail. So 320 out of 1,000 favor sin tax on junk food. We want to create a 99% confidence interval. Okay, so how do we do that? Make sure I'm setting this up correctly. A 99% confidence interval. Excuse me. All right, so looking at the prompt, I want to get a 99% confidence interval. All right, the formula is your statistic plus or minus Z star times the standard error. So we need 3 bits of information to get the confidence interval. We need the statistic, Z star, and standard error. All right. The statistic is we have a proportion, 320 out of 1,000. So I'm going to write this as p hat equals 320 out of 1,000. Right, and that'll be 0.320, or 0.32. So I got my statistic. All right, 99% confidence. I'll just put here to get Z star. I'm going to use stat key. Normal distribution with, excuse me, let's put that away. Okay, we're going to use a normal distribution with 0, 1. So Z stars equals. So I want to go to stat key. Here I'm in the normal distribution. But if you're in the main screen, click on that normal. Make sure the mean and standard deviations is 0 and 1 respectively. Click on two-tail, always two-tail for confidence intervals. And that center area, the center region, this should be the proportion or percentage we're looking for, and that's 99%, 0.99. Click OK. And mine's going to be 2.576. Right here would be 2.576 is my Z-star. So I've got the statistic, Z-star, and now how do we get standard error? For now, we get standard error by creating a bootstrap distribution using stat key. We will calculate standard error using formulas in chapter 6. So this bootstrap distribution, this is much more modern, really the last 25 years or so, because you need fast computers to get this bootstrap distribution, like modern computers. We're going to go back to the more classic standard way of calculating these formulas, how people did statistical analysis 30 years ago, 40 years ago, 100 years ago without computers. They had to use these formulas. But for us, right now, either the standard error is given, or I need to go to the bootstrap confidence intervals and click on confidence interval for a single proportion. I want to edit data, because our sample data was, 320 out of 1,000. Too many zeros. So 320 out of 1,000. I should see this over here, 320 over 1,000. Generate, I like doing at least 2,000 samples. And right here we have the standard error is 0.015. Standard error is 0.015. So then the confidence interval is, I'm going to take the statistic, 0.32, add and subtract 2.576 times the standard error, 0.015. I'll write this out in a couple steps. I have the statistic 0.32. I'm going to multiply these two together, 2.576 times 0.015 to get 0.03864. And then this is going to equal a range. So if I subtract that from 0.32, I get 0.28, around 2 decimals at this spot. And if I take that 0.32 and add 0.03864, round that to 2 decimals, I get 0.36. All right, and if we look at interpretation, we are 95% confident. Let's go back. 99% confident that between 28% and 36% of all U.S. adults support a syntax on junk food. All right, so we have the sample statistics, 32%, and it looks like we added about 4% to get a 99% confidence interval. All right, well, here is a bootstrap distribution. I just showed on stat key. I took a screenshot. Standard deviation is the same, rounded to 3 decimals at least. So notice we've got a normal distribution, nice bell-shaped distribution. There's your standard error, 0.015. And kind of going through on the slides, what I already did on the Word document is to take that formula, put your Z-star standard error statistic together in the formula, And we got, we're into 3 decimals, 0.281, 0.359. As I already said, we're 99% confident between 28 and 36% of US adults favor syntax. All right, so if distribution of statistics is normal, we're going to use this new formula, although it's very similar. Only difference is this Z-star that samples statistics from your original data. The Z-star is from the normal distribution, centered at 0, standard deviation 1. And the standard error is from the bootstrap distribution. So notice if you wanted to create multiple different confidence intervals from your same sample data, the only thing that would change is this Z-star. All right, it would be nice if we can compute the standard error without doing all those simulations on the stat key. And we can when we get to chapter 6. Chapter 6, we'll go to the more classic, the standard methods of calculating standard error.